Hello everyone, Obiora is here. Today we'll be looking at understanding neural networks. Here we're talking about artificial neural networks. That's artificial intelligence. We've talked about machine learning, talked about deep learning and artificial intelligence. I think one of the days we discussed that. So now we want to talk about neural network, how especially when we talk about deep learning, how does it work? Deep learning uses neural network, and that is why this is very important. So neural network is a computational model inspired by the structure of the brain. Human brain is designed to recognize patterns and solve complex problems by processing information through interconnected neurons arranged in layers. Yes, that's similar to how the brain works, but to be honest, the brain is more complex than this. But that this principle or the mode of functioning of the brain is what is copied, as it is said. Of course, the best science is the one that copies nature. Yes. So this is what it's doing, copying the way the brain works, and by that processing the machine's information. And that's the best way it can do, especially when it comes to unstructured data like image. And that's why it's used in image recognition, natural language processing, where you can communicate in just give a prompt and he able to give you your answer and just with correct prediction. So that's how it works. In with For a normal natural brain, human brain, it takes we when we look at things, we there is an input. We have our senses that takes information. It's either you are taking through the eye, or you are taking through the ears, or you are taking even through the nose, or even our feelings. When you match step on a rock or something like that, there is like sensors all over your body, right? Taking the information right to the brain with speed. I mean, the design is interesting. And right there, immediately, the thing is interpreted, the complexity is in another level, you see. But that's the processing uh, pattern that machine also, so it takes input, then there is an activation, there's a processing function or activation function where it considers the information that comes like in electrical, like in electrical energy form or something like that, impulses, electrical impulses, and is weighing it whether it falls into a particular pattern and chooses if it should accept it, that's fire it or not. If it is not in a particular threshold, or it is not in a particular bias, it will not be fired. Like the way our brain learns, we learn by experience. A baby learns by experience. When he keeps seeing this, you develop a bias over that thing he's seeing and make judgment on that. And this is how things are. That's why when we say somebody is biased in judgment, we are saying that the person has accepted a particular data and wouldn't change with that data. It takes it like that. And that's how computer also have copied to learn. Takes up a feature, and that is why in machine, in artificial intelligence, there's aspect of training with a particular model. These are mathematics, I mean, mathematical models and all of those kind of things. But the idea is that after the processing, there is an output of judgment to say whether to make the prediction how it is or not. So that is it. So if you understand human brain, you easily also understand the concept or the idea of what neural network is all about. So there is an input layer, there's a hidden layer, and there's an output. So, and that is what's all about. It is organized in that first place of getting the raw data. It is fed into the network. Each node in this layer represents a feature of the inputs. For example, each node, for example, it's like you get a team, each one has a department. Okay, this team, let's break down this we bring an image, maybe image of a tree or a car or anything or a human being, and say, let's break down this thing. This team be in charge of the lines. This team be in charge of the color. This team be in charge of the shape. This team be in charge of maybe texture. So the first team takes up the line, they make their judgment and say, oh, we have concluded that this is what it is. Then they push it to the other team. The other team make their judgment that they won't start trying to do the work of the first team. They only put on top of what the first team have done, they will add their own judgment. That's how it keep moving from one team to the other, from one layer to the other. Here we are talking about layer. I'm just using team as an example. From one layer to the other, then right to the output, we get a whole form. And in most cases, the first movement, it will not be correct. So there will be movement back and forth. We'll talk about that. There's forward movement, there's backward movement. It goes on many times, and then with that training, it can say, yes, this is what it is. So there's an input information, a raw data. It goes through this layer, that's the thinking layer, where the information is processed, then is now by weight. There's a particular weight, just like you say, you set up the your room temperature and say it should be in this value. If it goes below this value, it shuts off. If it goes above this value, it shuts on, something like that. So there is a threshold, there is a level that when that's the value that is sent, the data is representing. If it gets to that value, it's fire. It gives it a go ahead. So it moves to the next layer. That's how we go until it gets to the output layer, which produces the final results of the network processing. The number of nodes here depends on the problem. That's the complexity of the problem. One node for a simple yes, no prediction, multiple nodes for classification. So that's how it goes. And that is it. The input layer, the hidden layers, and the output layer. So the series, all these things we are talking about, they are coming in form. The whole, like if it's a picture, the picture will be represented with pixels, and they will be represented in form of arithmetic and uh, formula, the function. Then in the computer, all these things moves as electrical impulses, and finally to the result. So, and then we talk about how it learns. The neural network, it goes forward propagation. The network makes an initial prediction by passing the data forward through its layer. When it goes forward, of course, the error will be high. There will be high error. Then it goes for back propagation. The network compares its prediction to the actual result. The difference, the error, is then propagated backward through the network to adjust the weight of each connection. This process minimizes future error. So it goes back and forth. When it's taking it back to adjust. So when the thing is not in the right result, it goes back, and then the system, the weight, the weight of that node to node, the connection, that line is adjusted to get the proper balance. It will keep adjusting the weight until it can get, say, okay, this is the best state of accuracy. Then it will be justified. So this cycle is repeated thousands or millions of times until the network's prediction are, yes, highly accurate. And at that time, you could say the judgment, the network, that machine have learned. So next time when the machine sees a man coming, it will not call it a dog, because the every node have gotten all the features they need about a man. So immediately a human being is coming in, maybe it's maybe a camera that is using face recognition. Merely a human being is coming. One node have taken the line, another node have taken the structure, the the surface, another node, everything brought together and aligns, and they say yes, the judgment, the prediction is this. This is a human being coming, and action will be taken as supposed. So in the real world application, we see it, especially in image recognition, tagging people in photos, self-driving cars, recognizing pedestrians and traffic signs. There's a natural language processing in AI chatbots, language translation and sentiment analysis, recommendation engines predicting what movies to watch or what product to buy on platforms like Netflix and Amazon. Then medical diagnosis, analyzing medical images to detect diseases. Now, there are many, and as technology improves, there will be more places to apply neural network. It's a very interesting field to, it's a very interesting area on aspect of knowledge to apply. And I hope what I've shared makes it simple to understand. But that's how I am able to for now. And I hope that as you deeper in the knowledge, we'll get clearer picture as time goes on. Thank you so much.